here. Readings on meter. Good job, good job. That's it. There's 59 parts. Alright, that's the welder we're using. Still getting my tungsten and cup set up. I think I'm just going to use the number 6. And this is going to be a 332 2% lanthanated tungsten, I believe. And I got a brand new pair of gloves. Shout out to Defiant Metal. I've been saving those to do some aluminum with. And we're going to have to flip the machine to AC. Not sure how many amps I'm going to run. I just cleaned everything off with the paint thinner. I didn't really have any acetone, but got them as clean as I can. They're drying. They're pretty much dry. But it's not fully brushed. I do got my aluminum brush there, so hopefully we can tack these up and kind of go from there. But I'm going to try the first couple pieces and try to get the amps dialed in. It doesn't need to be some crazy welds, it's just going to be some tacks. So that's what we're working with today. 90 amps on the AC, 33 hertz, 33% AC balance, and 70 hertz on the frequency. 18 CFH argon, number 6 cup, 332 lanthanated tungsten, 1/8 diameter, 4043 filler rod, and I'm ready to blow this thing into smithereens if it doesn't shock me. So hopefully I don't gotta put my ground on this wrench. We can get a nice first tack on this aluminum sheet metal. Well, had the most wild sound to it, and that's not what I wanted or expected. Everything just kind of sugared instantly, and it is quite hot. Okay, what went wrong here? Most people would probably say I didn't clean the metal enough. So let's clean some metal. Alright. Trying it. Seems too hot. Downslope is too slow. Not sure if that even hit. Oh my gosh. I don't know why it's doing that. Definitely something is not correct. I just don't know what it is. It's probably just me. Somehow. Like always. It appears to be welded though. And these welds don't need to be the prettiest, they just need to stick and be hidden. So we're gonna go with that. A few of these first tacks, I had the fan blowing air towards me, and I didn't realize that I was blowing all the argon away from the weld. I still got them tacked, but once I turned the fan away, I noticed the welds were, well, the tacks were getting a little easier to manage, a little more predictable, a little easier to control when you're not blowing that argon around. I believe I had turned my frequency down to about 30 or 40, I think, and this seemed to do a better job of bouncing the puddle to stick attacks. And once I turned the frequency down, things started going a little smoother for the most part, and I left it there. I thought the higher frequency was going to let me have a more precise tack, but it seems like the lower frequency was better for the job. Same AC balance, I believe, but just a lower hertz frequency. Finally, the first rose is starting to take shape, and still have a lot to go. So this is where I realized that if I really drive the filler wire, just really shove it in the puddle there, that I can build up enough to prevent the edge of the leaf from melting away so much. And once I started really forcing the filler in, probably more than I should have, but I was able to build up a nice little button of attack, as you can see here. And to me, that felt like some progress, and took more filler than I expected. So one more pedal on there, and that much more to go to finish this one out. I was piecing them on one at a time, just trying to find the best spot to create the most realistic looking rose I could. And I created a little method of finding the spot I wanted, adjusting if I needed to bend, and then I would use the vice grip. Here I'm making adjustment on the bend, and then I would use the vice grip to kind of clamp it to the part, and that would hold it for me to make my first tack. And then I could take it off, brush it, and then hit the second tack. And I was usually doing 2 heavy tacks on each part to add to the back, and this seemed to work out for the most part. Once I got the settings and technique mostly figured out, it was still challenging, but by the end I was a lot better than when I had started. Still not perfect, but I did drop it a few times, and it reassured me that the welds the tacks were holding it together. I expected it to shatter apart when I dropped it the first time. But I dropped it many times on accident, and it held together, so that made me a little more confident in these little tacks here. So here, like I mentioned, I have the piece prepped and bent, and just trying to clamp it into position here. These needle nose vice grips, they worked pretty good. And as you can see, holds it right in place, ready to take the tack. And here we go.
Because you're dealing with outside the government now, presumably, if you have a defense contractor, that's an independent company. Not necessarily, even though they work hand in glove with the government, they're not necessarily a part of the government. So
in fact, if you put your thinking cap on, you'll say, okay, this would be the way if you want to keep it out of the public.
because you don't have to disclose it.
You know, give it to a contractor.
Right.
Okay, this is your stuff, and from now on, you own it.
But how do you control it, though? You have to have government agents embedded deeply in that, which I assume they do anyway. But you have to have intelligence agents I hope they do, deeply embedded.
So texture of it and so on. And Jamie, can you pull up that first of the? It shows the wooden figurine and the tape measure. So on a given day, you have 2 objects, of course, they're different as they can be in case you get a lousy description or whatever. So on a given day, that's a couple of objects I picked out. Then I label the one to myself, I label the one on the left, mark it up. The one on the right, mark it down. But they have no idea what my objects are.
Right.
So the next day, you get the following slide. Yeah, following slide.
Previous.
Yeah. That's it.
So now, when going into the future, you're reasonably certain that these things, this is a real phenomenon. Do you ever get access to these materials that you were discussing earlier? Have you ever seen anything?
Yes, I have. One example I can talk about, one sample I can talk about.
But the things you can't talk about?
I burned the edge of the leaf a little bit, didn't add enough filler rod on that one, but no worries. Nothing, a little wire brushing, can't fix. It's definitely not gonna fix it, but leads are imperfect, and a little pickle juice to cool it down. Yep. And keep on keeping on. One leaf at a time. Here's how it's looking so far. A little flash to the camera. And repeat.
Of course, we have data, can't go into detail, we have data about crashes in other countries. There's no way to tackle.
Right, and if these are very unique moments where this is an extremely devout person who obviously was a monk, was probably meditating and achieving this insane state of consciousness that's almost impossible to get to unless you're committed as long as he was, unless you're as dedicated as he was, and then he has this overwhelming
Right. And there's no way to connect the physics to it.
But the idea is that if there is energy that's allowing a person using their mind to do this, that somehow or another, if this energy can be accessed through science, through physics, through engineering.
We tried to look into that, for example, Andrei Sakharov, a very famous Soviet physicist, said, I don't think gravity is its own thing. I think really it's a manifestation of the underlying quantum fluctuations. They were seeing what we call NHI craft.
So here I decided to mute the audio because I had something playing in the background. Don't want to get a strike situation, but the tacks were going a little bit smoother for sure. Aside from the occasional tungsten sticking, every now and then I would dip or stick the tungsten, but it was so balled up that I really just kept going. I would maybe brush it off every now and then, but it didn't seem to affect it too bad. But then again, look at those welds. So, like I said, just tacking them up, they didn't need to be picture perfect. And speaking of picture perfect, my hand was blocking the view there. I'm a one-man show over here, just trying to get some good records, but at least it's in focus when I move my hand. Also, I was attracting quite a few bugs with the weld light, and that was kind of annoying. Not as annoying as flicking the whole piece off there, but I did feel bad for those bugs because they really had no clue what they were getting themselves into right here on the workbench. So I apologize for that. And I got the piece off the floor, and every time I dropped it, it seemed to held up to the impact. So here's a recap of how it's looking. I'm working on the outer perimeter now, wrapping around the leaves that bend out a bit more, petals should I say. And with this technique I just kept going. It's pretty simple and repetitive. I'm sure there's a lot better welders out there that would have made this quick work, but like I said in my last video, this is my first metal sculpture project, and also it's aluminum, so in my opinion just a little bit less forgiving and slightly unpredictable with the puddle actions there. I was trying to show the balled up tungsten there, but it was out of focus. Rest assured it was quite balled up and not the prettiest, but definitely the globbiest. So we were globbing them on there, and I just didn't want them to break off after I moved on. I was okay to have a glob here and there because the next pedal usually was covering the last glob attack. So just working my way out through each part. There were some mishaps along the way, a few misses, and each piece was slightly different angle and whatnot, but for the most part they all went I don't want to say smoothly, but they all went, that's for sure. This should be a better angle of the shot there. No arc shot per se, but you can at least see my torch angle and how I'm up in there. Got a little sticky there. No big deal. Fire back up. Melt her in. And keep on keeping on, brother. Look at that thing. the sound of the AC was nice to hear, but the sound of the fan on the machine was not so nice to hear. And I'm working on the audio quality of these videos. I don't want the audio to be too loud or too quiet, and it's just taken a little bit of learning to figure out these settings here. Trying to keep the volumes within a certain window, but when I do the voiceover it tends to be a little quieter. So I was looking into noise gates and filters for certain sound levels, but it all became a bit out of my league there as I looked at all the settings. So hopefully we'll grow into better audio if y'all can bear with me in these early stage productions of mine. So that block that I have there, I will mention, is just a bar of aluminum. Picked it up at the local scrap yard and cleaned it up with a wire wheel. It's a pretty nice chunk of aluminum that I use on the welding bench for different things, weight to hold things down. It's not too heavy, but it is a good heat sink, and in this case I'm propped up against it and just using it to kind of hold the part up and trying to do a good job at keeping the contact to the bench for the ground. And as you can see, it's a little tricky to balance with that vice grip. And another tack. And the bugs love the light, but I don't think it's what's best for them. And that one globbed up a little bit on the filler wire, but I was trying to just drive it in as much as I could to fill that void between the leaves there. And this should be the second tack for that pedal. And speaking of pedal, I'm not using a pedal, I'm using the finger button. I don't have a pedal yet for my rig. Just at least it's a high freak, but just using the finger button to activate the welding machine on each of these welds. And it takes a little getting used to, and a lot of people don't like it, but that's what I'm working with, and it's kind of growing on me. It's not a pedal switch, it's just an on-off switch that came with the rig, so I could upgrade to the foot pedal. It takes a 5-pin, so if you know a good 5-pin pedal, leave it in the comment below, and I will definitely check it out when the time comes. I figured if I could get away without using the pedal, then once I did get the pedal, I would be that much further along on my TIG progress. This machine does do pulse, but I'm not using any pulsing here. Didn't really cross my mind. It may or may not have been a good idea, but the pulsing was very good when I did use it before. And I realized where the pedal would come in though for manual pulsing, and also tapering out on the heat to try to avoid undercutting when the piece gets hot.
Results in that negative pressure that wants to pull those two plates together. That's called the Casimir force. A guy by the name of Casimir was the guy that derived that back in 1948, but it took us until the late 90s to actually measure this in the lab to the physics community's satisfaction. And so it's been studied hundreds of times since, measuring forces at different regimes, if you will. And there's also something called the transverse Casimir force. So when you try and slide those two plates together towards one another, the vacuum wants to resist you sliding those two plates. And so this is a very real phenomenon, and it's a wonderful illustration of the peculiar nature of reality at the microscopic level, right? So, the theory was worked out in the late 40s. The experimental stuff was started in the 90s, and there's been a bunch of work since then, and I think they're even looking at trying to use the Casimir force in MEMS devices. But all that to
MEMS device?
Micro electromechanical machines, some small gears that you can't see with your eyes, but they serve different purposes that people are trying to come up with for sensors, maybe some things in your cars with future chips that might be in your phone or something like that. Things that when they make micromechanical systems that they make them with a light because you can't even see those kinds of things. So the quantum vacuum, this fluctuating field of particles and forces and so forth, is a very real phenomenon. And so this stuff I just described to you is the negative vacuum energy density that Alcubierre highlighted in his paper when he said, we don't know how to make exotic matter in general relativity, so that circle on the Venn diagram doesn't tell us where to go. But quantum mechanics tells us how to make negative vacuum energy density in the context of what we see in a Casimir cavity. And so maybe we can, some future generation of scientists will figure out how to do something in some way to, like if you ask what's in those rings around the IXS Enterprise, right? Maybe it's some deeper understanding of the nature of the quantum magnet. And point in fact, I talked to you about, you asked me when might this happen, and I said, I can't tell you when, but I know what I need to be doing next, right? So in my mind, I think some of the next big chapters in physics are going to be centered around understanding the nature of the quantum vacuum and the quantum field. I think there's going to be a lot of fruit there. That may provide us the opportunity to add more circles to the Venn diagram, or maybe expand one, or what have you, and so forth.
So what kind of experiments have to be conducted in order to expand this? So you're talking about things that are going to be achieved in particle colliders, but how are they, what do you anticipate?
That's a good question. So there's a lot of different approaches people have taken to try and explore the nature of the quantum vacuum. And you can even start to look at cosmological observations and talk about dark energy that's equated to the quantum vacuum at scale, the cosmological scale. I think there's even some recent stuff that's come out in the peer-reviewed literature that the cosmological constant may not be constant. It may actually be changing over time. And so there's some experimentation. It has nothing to do with the They look at the people that do work on that, that's not space work, but they're trying to understand the nature of the cosmological constant, the quantum vacuum at scale. So there's a domain where some interesting work might be done. I know universities all over the globe still do work today with studying the Casimir force. They make different types of things, different materials and so forth, just to try and understand how materials respond when they make these small things, and trying to understand how the quantum vacuum works with it. But I think there's also some other things that we can try, right? And so that goes, I think you've seen some of our work that we've been doing, right, with some nanostructured devices that we've been doing some work for DARPA for a number of years, where we're actually trying to work on some systems that generate power. And so in the process of doing that, we've actually found that our nanotechnology may actually have some intersections with the idea of the space.
So I thought that was an interesting clip, and that green light right there was from, I believe, touching the filler wire to the tungsten by accident. And right here I'm propped up on some little pegs trying to hold this piece as I tack it, because there was no real good way to clamp it. And I believe I got it worked out. And I had to do this for quite a few of the smaller pieces on the bottom structure of this. They were just a lot smaller and had a different angle to them, kind of curling out at the bottom, and there, like I said, there was not a very good way for me to clamp it, so I had to get one tack on there before I could move it and tack the other side. I think this was a great angle, the shot there in focus. And time for the pickle juice, but since it's muted, I need to do the sound effect for you. I think I did it too slow. It might have been more of a like a... There it is, in all its glory. Almost done with the first rose there. As I get ready for the next part. As you can see, those bottom pieces kind of add to the post-bloom curl, I guess. That would be something like that when the flowers in the later stages of the bloom, those petals start to open down below. Yes, and here's the first leaf. Pretty tricky. See me here kind of struggle along with it. Took many tries to get that tack to stick there. Such a small part. Might have had my voltage too high or my amps too high, something like that, and it's tricky though because it needed a puddle, but it couldn't melt it. So enjoy watching me fight with this piece to get it tacked, and I finally did, but like I said, it took me many tries. I also wanted to mention that I forgot to record me making the stem of the rose. You could see it there in the background as I'm working on these leaves for it. I can explain what I did. Was pretty simple. I took two pieces of filler wire, 1/8 4043, same filler wire I've been using, and I took a full length and I cut it in half, and I put those in my drill chuck and the other side on vice grips, and I put those in the bench and just turned the drill and twisted it until it pretty much braided all the way down. and then the third piece I wrapped it around that so that it kind of added some dimension to the braid. And so that one was a 2-wire twist with 1 wire wrapping around, essentially. And on the other stem, what I ended up doing was a 3-wire twist, so that there was some variation in the stems. And then where the 3 wires connect to the back of the rose, I just spread them apart and then tacked them each into the back of the flower and globbed it up real good so that it would stick. My shoulders blocking the view a little here, but there's not much to see anyways except for a few failed tacks. And I was arms in the air. What's going on? Why isn't this thing sticking? And I'm sure I just wasn't really breaking through the oxidation layer. And then by the time I did, I would melt down the filler wire. So it felt like I was dabbing, but it wasn't getting a full stick. So can't remember what amps I was, probably around 30 to 50, somewhere in there. I was trying it. I kept bouncing around, trying different things. And I thought it would be as simple as just blast it and stick it, but even right here, when I thought I had it, it broke off real easy, and that was a no-go. I wanted it to be a good solid tack so the piece could, be strong. So I thought I had it there, but no-go on that one. Wipe the soot and try again. So this time I figured I will just put a bunch of tacks along it, and it's got to grab somewhere, right? And it seems like it's holding. Let's get the other side real quick before it breaks off. And I ended up deforming that lathe quite a bit, but I did end up getting it. Here you can see the stem attached, and I'm just showcasing that. Really was proud of how it looked, but I was still far from finished, as I had one more to go, and the base plate, the pot that they go in. So this right here is the beginning of the second rose. This is the centerpiece of it. And with my new system figured out, I was underway with it. I was getting cracking, trying to waste no time. This section was a little difficult to clamp up, and here's how it's looking. I ended up clamping it a different way. This was just for the bottom leaves, petals underneath the main leaves. And I was afraid to clamp it this way, but it turned out that it was pretty strong. I was afraid I was going to shatter it, but it held up. Just using a block of aluminum to kind of prop everything. And just jamming the filler in there, trying to make things stick. Started feeling like I was getting the hang of it by the ending here. Getting nicer tacks. And let's see. There is a almost finished product. Kind of turned out better than I expected, honestly. Got the little leaves on there, got the stem on there, and I just had it clamped up to the table, and it was holding itself up pretty good. There's a close-up shot of the main flower portion. A couple of the boogers in there. At first I wasn't happy with them, but I guess it added a little bit of texture and realism. So now I just have to attach these extra leaves on the stem here. I'm trying to carefully not burn through that filler wire stem. Like I said before, probably the most challenging build that I've taken on. But definitely the most rewarding. So here's a mock-up, I guess. I'm pretty much done with it, like the way it turned out. The only problem is the cup. The weld on it turned out real bad, and I'm low on gas, so I just started grinding it down. Got a lot of undercut. Other than that, would have been done already, but you know how that goes. So I'm not sure if I'm gonna keep grinding it tonight or probably just come back in the morning and either grind it or re-weld it. But I'm low on gas, so we'll see. Anyways, all aluminum, TIG welded rose, Mother's Day. The pot's steel though. And I ended up putting some rocks in that cup just to hold everything down. Added a nice look to it. So that's it, guys. Thanks for watching. There's some pictures of the finished product, final project. Thank you.